So, good morning all. Today we are going to discuss about few more numericals related to the formulas what we have discussed in last few classes. Okay. So today around 4 to 5 questions we are going to solve, which will be similar to the previous class but little bit different. Okay, so one by one we'll start. 1 minute. Okay, so first question is a carrier of 10 cos 2 pi into 10 to the power 16 is amplitude modulated. Amplitude modulated by a message signal that is called our baseband signal, or we can say it is called as our modulating signal, whose strength of 4 cos 4 pi into 10 to the power 3t, okay, with 50% of modulation, 50% of modulation, okay. And what we have to calculate, and the hint is given: antenna resistance, okay, antenna resistance given as 5 ohm. This is the hint, and we have to calculate, find all parameters of AM. Then first question. Second question is we have to plot AM spectrum. Okay, AM spectrum. So this is the given question, spectrum and the spectral component. Okay. Now, as per the question, we have to go through step by step that what are the given functions are there, and what are the parameters we have to calculate, and what is the hint is given. Okay. So this question is similar to the previous class what we have discussed. The same thing, but little bit changes is there, that we will see. So as per the given question, given data is our C of t is equals to 10 cos 2 pi into 10 to the power 6t, and our message component, which is equals to 4 cos 4 pi into 10 to the power 3t. Okay. Now these are the two functions, and one more important thing, capital M 50% is given, from which we can determine the modulation index is 0.5. Then, so these are the functions what it is available in a given question, and now we have to identify the all parameters of AM. All parameters of AM means you have to calculate transmitted power, okay. We have to calculate carrier power, okay. We have to calculate sideband power as well as lower sideband power and upper sideband power. And what else we have to calculate? We have to calculate efficiency. So these are the fundamental parameters of an AM through which we can identify whether it is a single tone or multi-tone. Now, as per our given question, our modulating signal is having only one frequency component. That means it is called single tone modulating signal. So whatever the modulated signal we will get, it will be as a single tone modulated signal. So one by one we will identify all these relations. First of all, and one more important thing, the antenna resistance is given as 5 ohm. This is the most important factor in order to calculate the carrier power as well as to calculate the sideband power. Okay. Now, if I want to determine carrier, as we know that it is AC square divided by 4R. Okay. AC square divided by 4R. Now, what is AC square divided by 4R? AC is how much? AC is 10. So, 10 whole square, here I will get 10 whole square, divided by 4 into R. R is how much? 5. Antenna resistance. This R is called as antenna resistance, where the potential drop will be there and it will be converted into an electric field. If current drops, it will be converted into an magnetic field, which we have discussed in the previous classes. So it is 100 divided by 20, so it will become as a 5 watt. So my carrier power is 5 watt according to this. It is AC square by 4R. Okay. Now how is AC square by 4R it came? It is AC divided by 2 whole square divided by R. Because AC RMS square divided by R means okay. So it is 2R and here also it is 2R. So it will become as a 10 and your power content will be 10. So it is 100 divided by 2 into 5. So it is 10 watt. So this is my carrier power. Now once carrier power is known, you can determine the transmitted power with the help of a relation with respect to modulation index. So PT is equals to PC 1 plus MS squared by 2. So what is PC? PC is 10 watt. What is MS square? MA is 0.5. So it is 0.5 whole square divided by 2 is equals to your power transmitted. You can calculate this one with the help of your calculator and you will get 11.25 watt it will come. Okay. So this is my transmitted power. This is my carrier power. So my sideband power PS is equals to or PSB is equals to PT minus PC. So PT is 11.25 and PC is 10 watt. So it is 1.25 watt. So this is the sideband power. Okay. So first we have identified the carrier power with the help of this antenna resistance. Okay. This is the power relations. Then after determination of this carrier power, we have determined the transmitted power. With the help of what relation? With the help of this small relation, that is PT is equals to PC 1 plus MS square by 2. MA is given as 0.5, substitute here, solve it, you will get 11.25 watt. Then sideband power, as we know that total power is equals to sideband power plus carrier power. So sideband power is equals to transmitted power minus carrier power. So transmitted power minus carrier power. So transmitted power is 11.25, carrier power is 10 and you will get it is 1.25 watt. Okay. Now once you have identified this sideband, you have to identify this LSB and USB. Okay. Now how to determine this? Very simple. So LSB is equals to upper sideband power is equals to sideband power divided by 2. So sideband power, how much we have got? We have got 1.25 divided by 2. We will get 0.625 watt. So this is my sideband power. Now once this sideband power is known, LSB and USB is known, next we will go for efficiency. Efficiency of transmission. So what is the efficiency? As we know that it is sideband power divided by transmitted power into 100. This is one relation, and one more relation with respect to modulation index, ms square divided by 2 plus ms square into 100. If you solve this or if you solve this, the resultant will be same. So what I will do, sideband power is 1.25, transmitted power is how much we have got? It is 11.25 into 100, we will get around 0.09, which is equals to 9% of transmission. Okay, so these are the small relations through which we will get around 0.11, it is 0.11, or we will get 11%. Okay, you can calculate. I don't have calculator, I have written these values. So the efficiency of transmission is 11%. Either you can go for this relation or either you can go for this relation. Both are same. Because if you solve these values, you will get ms square divided by 2 plus ms square. Ms square is how much? 0.25. Substitute here, you will get 0.25. Here 2 plus 2.25. If you divide it, again it will become as a 0.11, and that will become as a 11%. Okay. So these are the parameters which it was asked in the first question. Find all these parameters of AM. So these are the all parameters of AM. Now another parameter is what? Bandwidth of AM, and what are the spectral components available in our AM signal. That will be seen. Okay. So from this equation you can see that omega c is equals to 2 pi into 10 to the power 6, which is equals to 2 pi fc, or I can write fc is equals to 10 to the power 6 hertz, or I will write 1 megahertz. Okay. Similarly, omega n is equals to 4 pi into 10 to the power 3 is equals to 2 pi fm. Okay, so fm is equals to how much? This 2 pi will cancel out, it will become as a 2 kilohertz. Then now what is the bandwidth of AM? So bandwidth of AM is equals to twice into the modulating frequency available in our modulated signal. So twice FM means 2 into 2 kilohertz is equals to 4 kilohertz. So this is my bandwidth. Now spectral components are what? Spectral components means, for example, if I am drawing only for the right hand side, I am not representing the left hand side. It is just as a reflection. We need not to worry about it. You can represent this one in one part only. Okay, so this is S suffix am of f, and this is f, and this is 0. Okay. Now spectral component of am means, since it is a single tone, that means how many spectral components will be there? 3 spectral components will be there. First one is carrier, second one is lower sideband, and the third one is upper sideband. Okay. So first I am representing the carrier component. So this is my carrier Fc. Okay. Then I will represent the upper side band, that is Fc plus Fm. Okay. And one is lower side band, that is Fc minus Fm. So these are the frequency component available in my AM signal. Now what are these components? Fc minus Fm, then Fc plus Fm, and what are the amplitude? That we have to calculate and we have to represent in this particular spectrum. Now as I have calculated that Fc is 1 MHz and Fm is 2 kHz and bandwidth is 4 kHz, that we need to represent here. So what I will do, I will represent the position first, then I will represent the amplitudes. Okay, simple way to represent it. So this is the spectral component. So first is Fc minus Fm, that is called lower sideband position, or you can say it is a lower frequency component. Now what is Fc? Fc is 1 MHz. And what is Fm? Fm is 2 kHz. Okay. Now 1 MHz I can write, it is 100 or 1000 kHz minus 2 kHz. So that means it is 998 kHz. So this is my Fm. Fc minus Fm, we have got 998 kHz. Okay. And what is our center frequency? Center frequency is Fc is how much? 1000 kHz. Okay. Now we will calculate Fc plus Fm, which is the higher frequency. Fc plus Fm. Here I will write 1000 kHz plus 2 kHz. So if I will write this one, 1002 kHz. So this component is 1002 kHz. Okay. Now from this figure also you can calculate what is the bandwidth. Now what is the bandwidth? The bandwidth is this much. From lower frequency component to the upper frequency component, if you subtract 1002 minus 998, you will get bandwidth is equals to 4 kHz. Okay, so this is the bandwidth. Either you can calculate with respect to this formula, or you can verify with respect to this spectrum analysis. So this is my lower side band, this is my upper side band. Okay, we have identified and we have represented. Now next comes what is the amplitude available in this particular spectral component. Okay, so here it is, first is AC by 2. Okay, the next one is how much? Next one is MA into AC divided by 2. And here also MA into AC divided by 2. Now how to calculate this MA? MA is equals to how much? Maximum amplitude available in our modulating signal divided by the amplitude available in the carrier signal. So MA is equals to 0.4. Then now if you substitute here, MA is 0.4 into AC, AC is 10, 0.4 into 10 is 4 divided by 2, that means we will get how much? 2. Okay, or directly you can write Vm by 2, so Vm is 4, 4 divided by 2 is 2. So here the amplitude available, I will draw this one once again. S suffix Am of F. This is the carrier, these are the side bands. Okay. Okay. This amplitude is AC by 2 means AC is 10, 10 divided by 2 means it is 5. Okay. This is upper side band Vm by 2, that means it is 2 because Vm is 4. Similarly, Vm by 2 it is equals to 2. Either this you can represent in terms of amplitude or you can represent in terms of power. Both will be as it is. If it is represented in power, just square it because it is V square by R equal. Okay. So it is 2, this is 2, this is 5. Now this is my carrier frequency. How much we have carrier frequency? Carrier frequency is 1000 kilohertz. Okay. Now this is the upper side band frequency Fc plus Fm. So Fc plus Fm, how much we have got? We have got 1002 kilohertz. Okay. And what is the lower side band frequency? It is Fc minus Fm. How much it is? It is 998 kilohertz. So this is the spectral representation of an AM signal, which is a single tone modulated signal. Okay. So this is the simple representation with respect to the given question. Okay. 1 minute. Now after this, we will go for one more question. So is it understood? First we have identified the lower side band signal. Second we have identified the upper side band signal. And then we have represented in the spectral form. You can also represent this one in left hand side also. Here I have represented only the right hand side. You can represent the reflection part, means minus Fc, then minus Fc plus Fm, minus Fc minus Fm. Okay. And this is your F. So with the help of this analysis, you can go for another question. Okay. The next question is a carrier of of 20 cos 4 pi into 10 to the power 6 t is amplitude modulated by message signal which is also called as modulating signal, or you can say it is called baseband signal, of having frequency having frequencies 10 kilohertz, frequencies 10 kilohertz, 20 kilohertz, okay, with modulation index, modulation index 0.6 and 0.8 respectively. Okay. Find all the parameters of AM. This is bit A. Find all parameters of AM, and bit B is the spectral representation. Okay. Now in this question, your modulating signal, what is this? First, carrier is available. This is my carrier signal. Then, which is amplitude modulated with respect to a message signal in which two frequencies are available. Now, two frequencies are available means what? What I have told you? That each and every modulating signal, if it is having only one modulating signal frequency, then it is called single tone. But if it is more than one number of frequency, if it is available, then it is called multi-tone. So here we are discussing about multi-tone, in which the modulation index is 0.6 and 0.8. Done. So this is your MA1 and this is your MA2 respectively. MA1 with respect to 10 kHz, MA2 with respect to 20 kHz. Find all the parameters of AM spectral representation. Okay. Now all the parameters of AM means what? You have to calculate transmitted power. Okay. You have to calculate carrier power. Okay. Then you have to calculate the net modulation index, because here there are two different modulation index and there you have to calculate the modulation index. Okay. After determination of modulation index, you have to determine the sideband power and upper sideband and lower sideband. So this thing you have to calculate with efficiency of transmission. Efficiency of transmission, which is equals to how much? MA square divided by 2 plus MA square. So these are the fundamental parameters which we are going to calculate for this particular signal. And what else? You have to represent the AM multi-tone modulated signal in terms of spectral representation. Means how many sidebands will be available. If there are one signal is available, as I have discussed in previous class, if only one modulating signal is there, three components will be available. If it is a multi-tone means if it is more than one number of component is available, suppose 2, that means there will be a 5 spectral components will be there, including the carrier frequency. 2 upper sideband, 2 lower sideband and 1 frequency component for carrier representation. Okay. So we will proceed to calculate this step by step. Okay. So first I will write the relation. So transmitted power whole into carrier power plus MA square divided by. Then in order to calculate MA, M1 square plus M2 square, which is 0.6 whole square plus 0.8 whole square. So here you can see 0.6 is 0.36, 0.8 is 0.64. That means resultant will be 1. So that means modulation index what we have got, net modulation index is 1. Next we have to calculate the carrier power. Okay. Now here one more important thing, when we are calculating the carrier power, as our relation says, it is AC square by 2R. Done. This R is the antenna resistance. If the antenna resistance is not discussed in any of the question, if it is comes in your exam, if antenna resistance is not given, that means by default you people have to take the antenna resistance as 1 ohm. So here no information means you have to consider the resistance of an antenna is 1 ohm. Okay. So if I substitute here, it is AC square divided by 2. AC square means amplitude available in the carrier is 20. So 20 whole square divided by 2, that means it is 400 divided by 2, which is equals to 200 watts. So this is my carrier power. Now once this carrier power is known, you can go for transmitted power. That is PT is equals to PC plus MA square divided by 2. So here PC is 200. MA is 1 because net modulation index we have calculated as a 1. So 1 square is 1. So here we will get 3 by 2, which is equals to how much? 300 watt. So this is my transmitted power. This is my carrier power. Okay. And sideband power is equals to transmitted minus carrier. So transmitted is how much? 300. Carrier is how much? 200. So your sideband power is 100 watt. Okay. Now next, P LSP is equals to P USB is equals to the sideband power divided by 2, which is equals to 100 divided by 2, which is 50 watt. So this is my sideband power according to the given functions or according to the given relations what we have identified. Okay. So these are the fundamental points which will be carried on in the future problem also, but the steps are this much. So if one important thing, if the resistance of an antenna is not given, that means you have to consider the R value as 1 ohm. Okay. If it is given, well and good, substitute the R value, but if it is not given, means you have to consider R value as 1 ohm. Now once this sideband power is known to us, next we have to calculate the efficiency. Efficiency of transmission. Then we will represent all this sideband. Okay. Now here whatever I have identified, it is the total sideband. Means in this upper sideband and lower sideband consist of 2 more sidebands are available that we have to calculate individually. This is the total sideband. I will represent this whole 50 points into upper sideband and lower sideband, because this is the lower sideband and upper sideband. If I will combine, the resultant is 50. Means this is the total sideband. The total sideband means 4 components are available, 2 upper sideband and 2 lower sideband. Why? Because here 2 modulation index are there. That we will calculate now. How? Let's see. For modulation index MA1, how much? 0.6. So as we know that the power available in the lower sideband and upper sideband is equal, I will write P LSP 1, which is equals to P USP, and what is the relations are there? It is MA square AC square divided by 8R. This is the power content of the LSP and MSP. Means LSP and USP power content. So what is MA square? MA1 square? MA1 square is 0.6 whole square. What is the power content in AC square? AC is how much? 20. So it is 20 whole square. Okay. Divided by 8. Because R we have considered as 1. Next. So it is 0.36. It is 400 divided by 8. Done. This is 2. This is 100. Okay. So this becomes 36 divided by 2, that is 18 watt. So that means with respect to MA1, with respect to first modulating signal, the sideband and the upper sideband and the lower sideband power is 18. Okay. Now similarly we have to calculate for the another modulating frequency whose modulation index is 0.8. Okay, so for 0.8, same steps we are going to follow for modulation index 0.8. Okay, again this one LSB for second signal, power content in the upper segment for second signal, which is equals to Ma2 square into AC square divided by 8R. Now R value we have considered 1 because nothing is given. So Ma square means it is 0.8 whole square. AC square means 20 whole square divided by 8. Okay. Now here I will write 0.64 because 0.8 whole square is 0.64 into 400 divided by 8. Again this one it is 100 and this one is 2. So it is 64 by 2, that means 32 watts. That means the power available with respect to the second modulating signal, upper segment and lower segment is 32. Now you can check the total sideband, total upper sideband and lower sideband. If I will add, how much I will get? So 18 plus 32. If I will add these two, I will get 50. Is it okay or not? Yes, it is okay. Power content in the LSB is equals to power content in the USB, which is equals to 50 watt. It satisfies. Here we are getting 18 for modulating signal 1 whose upper sideband and lower sideband is 18. Similarly for second modulating signal we are getting it is 32. Okay, so if I will add these two sideband power, it must be 50. Okay, so it is having 50. So it is proved. That means the sideband power what we are available in our multi-tone signal is equally distributed, and if I will add these two, then resultant must be 50. Okay, so this sort of questions may come in your exam with respect to different modulation index. Now next we have to represent in the spectral representation. Okay. Now the spectral representation is, again it is a simple one. Only we have to identify the positions and represent with certain frequency component. So since it is a multi-tone modulated signal, S suffix am of f. First, I will represent the carrier frequency Fc. Okay. Then the first lower sideband. Then the upper sideband, and then the second upper sideband. Here I will write Fc plus F1, Fc plus F2. Similarly, here I will represent Fc minus F1, and second this lower sideband Fc minus F2. Then first I will discuss with respect to frequency, then we will go for the amplitude available in our multi-tone signal. Now since there are two modulating signals with two different frequencies, we have 5 spectral components. 2 upper sideband, 2 lower sideband. Okay. So first I will identify Fc. Now as in our question, C of t is equals to 20 cos 4 pi into 10 to the power 6. T is given. So now if you solve this to find out Fc, omega c divided by 2 pi. Omega c is 4 pi into 10 to the power 6 divided by 2 pi. You will get 2 into 10 FM1 it is given 10 kilohertz and FM2 is given as 20 kilohertz. Then now we have to find out FC plus F1, FC plus F2, FC minus F1 and FC minus F2. Okay, so one by one we will find out. So FC plus F1, that means upper sideband 1. So FC is how much? 2 megahertz. F1 is how much? 10 kilohertz. Here I can write 2000 kilohertz plus 10, we will get 2010 kilohertz. Okay. Then FC plus F2 means FC plus F2. F2 is how much? 20. So here we will get 2020 kilohertz. FC is 2000 and F2 is 20 kilohertz. So we will get 2020 kilohertz. Then this is the upper sideband frequency of the second modulating signal. Next we have to calculate the lower sideband signal. Lower sideband frequency component. So first FC minus F1, which is the LSB of first modulating signal. So FC is 2000 kilohertz and F1 is 10 kilohertz. So that means if I will solve this, how much I will get? I will get 990 kilohertz. Okay. Similarly, FC minus F2, which is the lower sideband of second modulating signal, which is 2000 kilohertz minus 20 kilohertz. Now if I will solve this, I will get 1980 kilohertz. Then, so here we can represent the position. First position is FC is how much? FC is equals to 2 megahertz. Okay, that we will represent here. So this is my AM signal. Okay. So first this is 0. So let us consider this is FC. FC is 200 kilohertz. Then second component is first LSB, first USB. This one FC plus F1. FC plus F1. FC plus F1 is how much? USB 1, it is 2010. So here I will write 2010 kilohertz. Okay. Then another USB, second modulating signal, FC plus F2. This is FC plus F2, which is how much? Which is equals to 2020 kilohertz. 2020 kilohertz. Okay. So these are upper side. Similarly, now we will represent for lower side. So first lower sideband is how much? FC minus F1, which is equals to 1990 kilohertz. And another one LSB for second modulating signal, it is 1980 kilohertz. That is FC minus F2. Okay. Now from this spectrum, you can also identify the bandwidth. So bandwidth means the lower frequency component to the higher frequency component. This is the bandwidth. So FH minus FL, Fn is how much? 1980. Fn is how much? 2020. So here I will write 2020 minus 1980 kilohertz. Now if I will solve this, I will get 40 kilohertz. 40 kilohertz. So this is the bandwidth of this multi-tone modulated signal. Now this is from spectral analysis we have calculated. Similarly, theoretical calculation also there. Bandwidth is equals to twice of Fmax. So what is Fmax? The maximum modulating frequency available in the modulating signal. Now in this modulating signal, two frequencies are available. One is 10, one is 20. So maximum is 20. So 2 into 20 we will get as 40 kilohertz. So which is same as this one. Okay. 40 kilohertz. 40 kilohertz. So this is the bandwidth. Now once this frequency component we have identified, next we have to represent the amplitude. That is the most important part of our signal. Okay. So either you can represent this particular either in terms of amplitude with potential, or we can represent in terms of power. Okay. So for this, if I will solve the carrier power, for example, 1 minute, I will write those relations, then I will put in that amplitude functions. So carrier power is AC square by 2R. Now AC is 20 square divided by 2. So how much it is? How much it will be? It is 400 divided by 2 is equals to 200. So that means my carrier power I will represent here as 200 watt. Then we have also calculated P LSP1 is equals to P USB1 is equals to 18 watt. Okay. So this is the LSP1 and this is USB1, so it is 18 watt. Done. And PLSP2 is equals to PUSP2. That we have calculated how much? That we have calculated 32 watt. So that total sideband power will be 50 watt. So 32. So that means my amplitude will raise up to this much. Up to this much. So it is 32 watt and this is 32 watt. So that means this is 18 watt is spectral amplitude is less as compared to 32 and 32 is less as compared to 200 watt. So in this I will represent only the amplitude 200 watt. This is 15 watt and this one 32 watt. 32 watt. So if you add these two sideband, that means total sideband you will get 50. Carrier power is 200. Transmitted power will be sideband power plus the carrier power. Okay. So these are the simple relationship or the representation of a spectral analysis with respect to amplitude or power with respect to the frequency component. So if it is a multi-tone, like this representation you have to make. First carrier, two sideband for first modulating frequency, two sideband for second modulating frequency, and your modulating signal consists of two frequencies with different amplitudes or same amplitude, but frequency may change. Okay. So depend upon this, these are the representation. We will proceed for one more question. Now one more question is, an AM signal is given by S suffix AM of t, which is equals to 20 plus 4 cos 8 pi into 10 to the power 4t plus 8 cos pi into 10 to the power 5t whole into cos omega ct. So this is the AM signal, okay? And here you have to calculate, find all the parameters, find modulation index, transmitted power, carrier power, sideband power, efficiency, and most important thing, bandwidth. Okay? Now how to start this one? First we have to represent the AM signal in terms of carrier and modulating signal with modulation index. Now this equation I can write S suffix AM of t, take 20 common from the equation, take this 20 outside, you will get 1 plus 4 divided by 20, because 20 we are taking out, so it is 4 divided by 20 cos 8 pi into 10 to the power 4 t plus 8 divided by 20 cos pi into 10 to the power 5t, okay, whole into cos omega ct. Then this equation is similar to the general representation of modulation index form A 1 plus ma cos omega mt into cos omega c. This is the general representation for single tone, but if it is a multi-tone, then I will write A 1 plus m1 cos omega m1t plus m2 cos omega m2t whole into cos omega ct. Now this equation and this equation is similar. We need to identify the positions. So for positions for carrier, if I will compare here, I will get AC is equals to 20. Done? Then M1 is nothing but this 4 by 20 and M2 is equals to 8 by 20. Okay? And what is the F1? F1 is equals to 8 pi into 10 to the power 4 divided by 2 pi, that is equals to 4 into 10 to the power 4 hertz. Okay? Similarly, F2 is equals to pi into 10 to the power 5 divided by 2 pi, that is 5 into 10 to the power 4 hertz. This is my F2. So these are the relevant representation of the data what we have extracted from the given AM equation. Okay? Now here individually we have to calculate first. What are the calculations we have to do? First calculation is the net modulation index. So how to determine net modulation index? There are two modulation indexes are there. So MA is equals to root over of M1 square plus M2 square. Okay. Now if you solve this, you will get 0.2 because 1 by 5 means it is 0.2. And this one 2 divided by 5 means it is 0.4 you will get. So it is 0.2 whole square plus 0.4 whole square. That is equals to root over of 0.04 plus 0.16 root over of 0.2. So this is my MA. MA is equals to 0.2. You can calculate it calculator and you can solve it. Okay. Next, what is our carrier power? Carrier power we have to calculate is AC square by 2R. Since there is no information regarding R, you have to consider R value as 1 ohm. So AC is how much? AC is 20. So here it is 20 whole square divided by 2. You will get 200 watt. Done. Similarly, the transmitted power is equals to carrier power whole into 1 plus MS square by 2. So carrier power is how much? 200 we have got. 1 plus MA square. MA is how much? 0.2 whole square means 0.2 root over whole square, it will become 0.2 divided by 2.1. So it is 1.1. So 1.1 means it is 220 watt. So this is my transmitted power. This is my carrier power. And what else we have to calculate? The sidewise power we have to calculate. So sideband power is equals to transmitted power minus carrier power. So what is my transmitted power? Transmitted power is 220, carrier power is 200, sideband power is 20 watt. And what is the lower sideband power? It is 20 divided by 2, that is 10 watt. Now one more important thing, this is the total LSB and total USB is equals to 10 watt. But in this case there are two modulation index are there, two modulating frequencies are there. So LSB 1 power and LSB 2 power we need to identify. Then if I will add those sideband power, it must be equal to 10 watt. Let's see how we can identify those values. So first of all, for M1, which is our 4 by 20, 1 by 5 or 0.2. So power content in LSB 1 is equals to power content in USB 1, which is equals to M1 square into AC square divided by 8R. Here R is equals to 1 because no such information is available for R. So here I will write M1 square AC square divided by 8 into 1. R is equals to 1 ohm. Okay. Next, we have to substitute. M1 is 0.2 whole square, AC is 20 whole square divided by 8. So this will become 0.04. This will become 400 divided by 8. So this is 100, this is 2 1 and USB 1 is 2 watt. Similarly, for M2 is how much? 8 by 20. 8 by 20 means 0.4. So, LSB of second, USB of second is equals to M2 square A square divided by 8R. Now M2 is 0.4 whole square into 20 whole square divided by 8. Okay. Now if you solve this, you will get 8 watt. Okay. Now 8 watt. Now the lower segment and upper segment for second modulating signal is 8 watt. A upper segment and lower segment for modulating signal first is 2 watt. Now if you add this 2 watt and 8 watt, you will get 10 watt. So this is the simple relation which need to be satisfied. Okay. Next, we will identify the bandwidth and the efficiency. So simple. Efficiency bandwidth is how much? Bandwidth is equal to twice into F max. F max. So there are two frequencies. F1 is 4 into 10 to the power 4 hertz and F2 is 5 into 10 to the power 4 hertz. Which one is the maximum? 2 into 5 into 10 to the power 4 hertz. So here I can say it is 100 kilohertz is the bandwidth of my AM signal, which is a multi-tone modulated signal. Now next, efficiency. Efficiency is how much? Either we can proceed for MA square relation or we can proceed for sideband power divided by transmitted power into 100. Any of this relation you can take. Okay. So your sideband power is how much? Your sideband power, as we have calculated, is 20 watt. Divided by what is the transmitted power? Divided by transmitted power is 220 into 100. So this will cancel out. 100 divided by 11. So it will become 9.99%. So this is the efficiency. Done? So this is the simple calculation. Here I have not asked about the spectral component. In questions they may ask to represent the spectral positions with respect to their amplitude or power content in it. Okay. So one more question we will solve and then we will stop. Okay. Small questions. Last question. An unmodulated AM transmitter power is given by 10 kilowatt. Okay. When the carrier is modulated by single modulating signal signal, transmitted power become 13.5 kilowatt. Find AM transmitted power. Transmitted power if carrier is simultaneously modulated by second message signal with 60% of modulation. 60% of modulation. Okay. So this is the simple one that we have to calculate, and we have to calculate the transmitted power PT. So how to calculate this? Step by step we will see. So as per the given question, first, as it was saying, it is an unmodulated signal is transmitted. Now this word itself indicates that unmodulated transmission means initially the given is modulation index is 0. That is the first hint. Indirectly it is saying it is unmodulated AM signal. So we had a relation PT is equals to PC 1 plus MA square by. Now if you substitute this MA is equals to 0, your transmitted power is equals to carrier power. As it was written, unmodulated AM transmitted power is given as 10 kilowatt. So this is 10 kilowatt. Done. Here no modulation took place. The transmitted power is equals to carrier power, which is 10 kilowatt. Next comes, when the same carrier is modulated by a single modulating signal, the transmitted power become 13.5 kilowatt. 13.5 kilowatt means after modulation with a modulating signal, which is a single. So it is single tone modulated signal. So here your power transmitted is this much. Now why this PT is this? Because it is after modulation the transmission power increases. Here no modulation means this transmitted power is same as carrier power. So carrier power we have identified. Transmitted power we have identified. We have to identify the modulation index. So modulation index relation, how we can find out? PT is equals to PC plus MS square by 2. Okay. So this MS square by 2 means it is PT by PC minus 1. So what is PT? PT is our 13.5. This is 10 minus 1. So it is 0.35, or MA square is equals to 0.7. So this is the first modulating signal. First modulating signal modulation index, that is MA square. 1 is equals to 0.7. Okay. So this is the first relation, MA square. As it was stating that first it is modulating with the first signal with transmitted power is this. So transmitted power for the first signal is 13.5. carrier power is 10. So modulation index for the first signal is 0.7. Okay. Next, find AM transmitted power. Now we have to calculate the total transmitted power. Okay, total transmitted power in which two modulating signals are going to be modulated, because as it is written, AM transmitted power is carrier simultaneously modulated by second message signal. So another message component is available whose modulation index is 0.6. So here MA2 is equals to 0.6. Done. Now MA2 is 0.6, MA1 square is 0.7. So what is your net modulation index? So net modulation index is M1 square plus M2 square. So M1 square is how much? 0.7. M2 square is how much? 0.36. So near about it is coming as 1. You don't consider this 6, near about 0.7 plus 0.3 it is 1. So near about 1 it will come. So this is the net modulation index. Now once this net modulation index is known, we can calculate the total transmitted power. Okay? Total transmitted power. So P total is equals to suffix T. This is PC 1 plus MA square by 2. Now PC is 10 kilowatt. We have identified 10 kilowatt. 1 plus MA square means it is how much? 1. So it is 1 divided by 2. So it is 10 into 3 divided by 2. So you will get 15 kilowatt. So this is the total transmitted power in which two modulating signals we are going to modulate, and then we are transmitting with the help of AM transmitter. So this is the total transmitted power in which two modulating signals are there. One with modulation index root over of 0.7 and another one modulation index 0.6. Okay. So for today's session we will wind up here. Next class we will start with the generation of AM signal. How many types of generators are there? What sort of modulators are available? And then we will discuss about the demodulation techniques. Okay. Thank you.